This is the video walkthrough of my NEA project, and so there's two modes, free mode and learning mode, and then I'm going to show free mode first. So on free mode we can see the white bars on the side of the screen and on the bottom. Those are the static gliders, so they are objects that have collisions but they can't move, so they'll stay still. And using the mouse cursor you can create a rigid body, which is an object that can move and has collisions. So if you click down either the left or right mouse button, you can adjust the initial velocity like this by the distance between your mouse cursor and when you first clicked. So then you can see if it has a velocity of 0, initial velocity, it will fall down due to gravity, and then when it hits the static glider, its y velocity will go to 0, so it will stay still. But if we shoot it this way, it glides on the x-axis, the y velocity will go to negative, the x velocity, sorry, will go to -1, whatever it is, so it'll just bounce off. And the next thing I'm going to show is collisions between rigid bodies. So if we place one like that, and then fire another one at it, you can see that they swapped velocities, so this rigid body here was stationary, and then this one here was moving, and then when this collided with that one, they swapped velocities. So that's to simulate the transfer of momentum with fully elastic collisions. And what I'm showing here when I'm scrolling around is that's using the middle mouse button. So if you click the scroll wheel and then drag, you can change the position of the camera, which is what perspective it's from. And you can have that camera mode, or if you press V, you can have it follow camera mode. So it will follow the selected projectile. So you can see if I launch a projectile, the camera will track it and follow it across the screen. And then you can use the right and left arrow buttons to swap between which one you're selecting. And you can see the one that's selected is highlighted in red there. And then to go out of camera follow mode, you can just click the scroll wheel again, and it will go straight out of it. And the next thing I'm going to show is the velocity time graph feature. So if you press G on the keyboard, and then it will plot the velocity of the selected projectile on the y-axis of the graph, along with time on the x-axis. And as we can see, the velocity of this one that's selected is 0, so the graph is just flat. But if we drop on here, you can see the velocity is negative because it's falling, and then it hits the ground, and then you can see that jump up there. Right, immediately the velocity goes to 0. And you can see again, if you launch one through the air, the velocity is negative, and then so we can see it goes, so the velocity was positive, sorry, and then here where it crossed 0 is when it started to fall, and then it hit the ground here, and then the velocity went to 0. And that's it on the free mode. And the other thing it shows the learning mode. So if we click escape to go back onto the main menu, and then you can click on the learning mode button, and then this is the learning mode. So up here is the question. So the question is randomly generated, and this is a question asking for the time taken. It tells you the initial velocity of the projectile. It travels for t seconds with an acceleration -9.8 meters per second squared. Final velocity is -10 meters per second, and then you need to calculate t. And so you'd use your calculator, use the SUVAT formulas, find what you think it is, and then you put your answer in. So if I think it's 56, and then when you press enter, it will show a simulation of what would actually happen if the initial velocity was 10 and it went for until the final velocity is negative 10, as you can see there. And we can see here that after the simulation has ran, it takes 2.04 seconds to get to that final velocity, so the answer is 2.04. So I was incorrect because I put 56. And then to go to the next question, you click this button here. And then this is a displacement question, so it tells you the initial velocity, and it travels for 2 seconds, and then calculate the displacement. So you put in what you think the answer is, and again, the simulation is going to run with those values, and it's gone for 2.04 seconds, and the final velocity is 42, and then you can see it tells you the answer there, and then we're incorrect. And then if I'll just click, 'cause it's random, so each time you'll get a different question. I'll just try to get a final velocity question. Yep. So it tells you the initial velocity, travels for 0.2 seconds, tells you the acceleration, and this time it wants the final velocity. So when you put in your answer, it will run the simulation. It only did it for 0.2 seconds, and then the final velocity is 6. So it tells you it there, and it was incorrect. And that's it.